Today we're going to be learning about place value with decimals.
Today we're going to be looking at large numbers, such as the one you see here. We're going to be talking about how to name them and how the various place values are related. Let's look at the number here. To help us name this number, we're going to look at a place value chart to review the different places. Here's a place value chart that can help us when we're naming numbers. Let's go ahead and start labeling the different places. The first thing we want to notice on here is the decimal point. The decimal point separates the numbers that are greater than 1 from numbers that are less than 1. We know the ones place is the first spot. Next to the ones place, we have the tens place. The next place is the hundreds place. The next largest place is the thousands place. After the thousands place is the 10,000s place. You might be starting to notice some patterns here. Next we have the 100,000s, and finally the millions place. Now if you're wondering, what about commas? Where do those go? It's always best to write down all your digits first and then place the commas in. We're going to go ahead and put the numbers, or the digits that we saw from the number on the last page, into this place value chart to help us name it. So I like to start from the ones place and move sort of backwards. Now that I have all of my digits in place, I can go ahead and put in commas. Remember that you want to count 3 from the back or 3 from the ones place and then place a comma. So I've got 1, 2, 3. Now we'll go ahead and put in a comma. And then I'm going to count 3 again to see if I can put in another comma. 1, 2, 3. There is a spot here for me to put in another comma. And then I can tell that I wouldn't have 3 more digits to put in another comma. Now when I'm naming this, the place value chart and the commas are going to really come in handy. The commas are when I'm going to stop and name what period I'm in. For example, we've got the millions period here. This set of 3 numbers is the thousands period. They all have the word thousands in their place. And then this set, the smallest one, is the ones period. Now there could be other digits in front of here. Remember, there is a 10 millions and 100 millions and a billions, and it goes on and on and on. But we're going to follow the same pattern no matter how big the number. So if I start here, I'd say 6, and then since I got to this comma, I want to tell what period I'm in. So I'd say 6 million. Now I'm going to look at just this next set here. This would be 753, and I've gotten to the comma, so I want to say what period I'm in again, 1,000. Now I look at just these 3 numbers, 333, and I wouldn't say ones because that would be silly. So let's put it all together. I've got 6,753,333. And that's how I'd say this number. We're going to come back to this chart in a couple minutes to take a look at numbers with decimals, but for now, let's talk about how some of these place values compare to each other. So here's our same number again, 6,753,333. You might notice that there are a lot of 3's in this number. You might be thinking, well, how do these 3's compare? Like, how many times bigger is this 3 in the tens place than the 3 in the ones place? Or how many times bigger is this 3 in the hundreds place than the 3 in the tens place? Let's take a look at some place value blocks to try to help us figure out the relationships between these different places. Let's say I wanted to know how many times greater the 3 in the tens place is than the 3 in the ones place. We can tell from looking at this picture that 3 in the ones place is the same as 3 of our small cubes, but 3 in the tens place, we've got 3 10 rods. If I counted these, I would have to count to 3 10 times to get all of these. So 1, 2, 3, that would be 1 time as many. 1, 2, 3, now I've got twice as many. 1, 2, 3, now I've got 3 times as many. If I kept counting by 3's and said how many 3's are going to fit into these 30 blocks here, I would find out that it's 10 times bigger. Similarly, if I wanted to know how many times does this 3 in the 30 go into my 3 in the hundreds place, I could look at the same model. So here I've got my 30 pieces, or my 3 10 rods, and here I've got 300 pieces, or my 300s. Now, if I counted this and I said how many 30s can fit into here, I'd have 1, 2, 3 rows. That's 1. 1, 2, 3 rows. So that's 2 now fit in here. 1, 2, 3 rows. That's 3 fit in here. And if I continue counting, I would find out that it is actually 10 times larger. I could also figure this out by saying 3 times what, or 30 times what, gives me 300. Because remember that this 3 is a 30 and this 3 is a 100. So you'll notice that each time I have the same digits next to each other, the larger one is 10 times bigger. I'm sure then you can figure out, if I ask the question, how many times does 300 go into 3,000, or how many times larger is 3,000 than 300, you could probably tell me it's 10 times larger. Again, it would be a lot more challenging to count this time because we're dealing with larger pieces, but if I wanted to see how many 300s fit in here, or how many times I would have to multiply 300 to get to 3,000, it would be 10 times. This tells me that anytime I have the same two numbers next to each other, the larger one is 10 times larger. For a bonus, you can think about how many times larger would it be if I was comparing the 3 to the 3,000. I've moved over, it's not 10 times larger, it's not 100 times larger, it would be 1,000 times larger. And I can use the place value chart and these blocks to help me figure that out. Now let's take a look at decimals. Here's the same number that we've been dealing with, but I'm going to pretend that this number also has some digits that are in our decimal place values. So I'm going to go ahead and write in some numbers here. What I did by adding that is now this number is just slightly larger than it was before, but it's not quite a whole larger. Remember that decimal amounts are amounts that are less than 1, but they're greater than 0. They're more than nothing. Let's take a look at what these two place values are. Now you might have noticed that as I move to the right on my place value chart, my numbers and the value of them are getting smaller, right? Ones place is definitely smaller than millions. So I can guess that these decimal place values are also smaller. So I'm thinking about places that are even smaller than 1. And I also learned in the last slide that when I was moving to the left, things were getting 10 times bigger, right? 1 times 10 would give me 10, 10 times 10 would give me 100, 100 times 10 would give me 1,000. So if I'm going in the opposite direction, instead of doing 10 times bigger, they're getting 10 times smaller, or they're dividing by 10. Now, if you think about 1 divided by 10, I'm thinking about one little piece, that little cube that we saw before, cut into 10 pieces, and just one of those 10 pieces represents the place value here, and we call it the 10th. Now, as I move to the next place value, imagine I'm taking that 10th, that was just one of 10 pieces of my little block, and I'm cutting that little piece into 10 smaller pieces, which would be very challenging to do because we're now dealing with very, very small pieces. So what's 10 times smaller than the 10th? It's the hundredths place. An important thing to note when we're looking at the decimal places, the places that are less than 1, is they all end with that THS. Now that we've got all of our places identified, let's name this number. I would call this 6,753,333. Now when I see the decimal point, I'm going to read it as and. So say and then I'm going to name this 45 and tell where it ends. It ends in the hundredths place, so I would say and 45 hundredths. Let's try naming another number that has a decimal. Here's my large number. I've gone ahead and put it into my place value chart to help me name it. I'm going to go ahead and put in my commas. Remember, I count 3 from the back, and I'm starting at the decimal point. I'm not starting over here. So here's my decimal point. 1, 2, 3. Put in my comma. 1, 2, 3. Go ahead and put in my comma. So I would name this 5,782,994 and 47 hundredths. Now, if I'm thinking about how some of these places compare, I notice that I have, two 4s next to each other. That means that the 4 in the 1's place is 10 times larger than the 4 in the 10th's place. I also have 2 9s next to each other. So that means that my 9 in the 100th's place is 9 times bigger than 9 in the 10th's place. And I can confirm that by checking my math facts. The 9 in the 10th's place is worth 90. If I were to multiply that by 10, I would end up with 9 times 1 is 9, add my 2 zeros, 900. And that is exactly what I have here, 9 in the 100th's place. We're going to end with some riddles. So my challenge here says write a number that has a 6 in the 10th's place and a 2 in the 100th's place. I noticed right away that this has a THS, so this 6 we're talking about, it must be a decimal. And this 2 that is asking for the 100th's place does not have a THS, so it's not a decimal. If you're thinking this is pretty tricky, I can absolutely use the place value chart to help me. But really, this riddle just has 2 restrictions on it. I'm going to go ahead and put my decimal point down. I know that the 10th's place is the first place after the decimal, and it says that I have to have a 6 in the 10th's place. So I'm going to go ahead and put a 6 there. The other restriction here, it says I need to have a 2 in the 100th's place. Let's see if we can find the 100th's place without using the chart. I've got my 1's place, 10th's place, 100th's place. So I'm going to go ahead and put a 2 in that 100th's place. Now there are some blank spots here, and I definitely have never seen a number that has blank space in between here and the decimal point. That would be kind of strange. So we need some placeholders here. The riddle didn't say anything about the 10's place or the 1's place, so I can put any numbers there I want. I can make it really easy and straightforward and just put zeros there if I want. I can choose any number I want. I can put a 7 and an 8. Whatever numbers I feel like can go there because the riddle didn't specify what I have to choose. What about the other digits? Like, we know that there's the 100th's place, or there's the 1000's place. I could put digits there if I want to. It doesn't say I can't. Or I could just leave them blank. My choice. I'm just going to leave them blank and keep it simple. This number would be 278 and 6/10. You could make a more elaborate answer that could even go into the millions or billions if you wanted to. Let's try one more riddle. Here's my final riddle. It says, write a number that has a 7 in the millions place and a 3 in the 10's place. Again, if you're feeling stuck with this, it's okay to use the place value chart to help you. I'm going to go ahead and put my decimal point down. Now I notice that I need a 7 in the millions place, 3 in the 10's place. There's actually nothing about tenths or hundredths, so I actually don't need to fill in anything in my 10's place or my 100th's place. Now it doesn't say that I can't, so if you want to add digits here, you can, but I'm going to keep it simple, and I'm not going to put anything in the 10's or 100th's place. I know that the first place larger than the 10's place after the decimal point is the 1's place. It doesn't say anything about the 1's place, so moving on to the 10's place. It does say that I need a 3 in the 10's place. Let's keep going. I have to go all the way to the millions place. So I did 1's, 10's, 100th's. I'm going to put my comma because I filled in 3 spots. Thousands, 10,000s, 100,000s. That's another 3 spots. Here's the millions. It says I need to put a 7 in the millions place, so I'll go ahead and do that. And all these other empty spaces here, I will need to fill them in because I can't leave blank spaces in between numbers. Otherwise, someone might just think, is this 73? That someone left a bunch of spaces in between? And that's not a number that has a 7 in the millions place and 3 in the 10's place. So I'll go ahead and fill these in with any numbers I want. Let's see what number I ended up with. 7,012,334. You'll notice that this number has a decimal point at the end, but then no decimal. Well, that's really not necessary. Since I decided to put no numbers in the 10ths and 100ths place, I don't really need the decimal point there to separate any digits that might be there. So this is probably the best way to write my number. Today we've talked about how to name the different place values, including decimals, This helped us learn how to name large numbers. And we learned the relationship between different place values. Remember that if a digit is the same in two place values that are next to each other, the larger one is 10 times bigger. And we saw that illustrated with some pictures.